Yes. Now exercise 1.4 I'm going to start. Exercise 1.4, the question is that without actually performing the long division, state whether the following rational numbers have a terminating decimal expansion or a non-terminating decimal expansion. Just we have to identify. Okay, very first part I took here 13 upon 3125. When we will prime factorize this 3125, then it will be 5 to the power 5. And here you can see it can be written in the form of 2 to the power 0 into 5 to the power 5. Whatever I told that if expression of this denominator will be written in the form of 2 to the power n into 5 to the power m, then it will be terminating. And here in this case you can see that 2 was absent, no problem, 5 was alone, but 5 came 5 times, and other than 2 and 5 any other number did not come here, you can see. So this is already terminating, so it has terminating decimal expansion, because in this case 5 is alone, 5 came 5 times, and if we write in standard form, then maybe 2 to the power 0 into 5 to the power 5. So here also we express there 2 to the power 0. So 2 and 5, two numbers are there. Other than 2, 5, any other number is not here. So it is terminating. And in second part also you can see, in second part, this is 29 upon, sorry, fifth part, 29 upon 343. Okay, 343 will prime factorize 343, then we'll get 7 to the power 3. And here in this case, 2 and 5 are absent. 2 and 5 are absent. Here in this case 7 is there, third number is there, 2 and 5 are absent. So obviously it is non-terminating but repeating decimal. Why but repeating? Because it is already written in the form of p upon q. So obviously this is rational number. Okay, and rational numbers have two types. Okay, either it is terminating or non-terminating but repeating decimal expansion. Okay, terminating or non-terminating repeating decimal expansion. So here we prime factorize 343 and we got 7 to the power 3 here. Okay, so 2 and 5 both are absent, so it is not expressed in the form of 2 to the power n into 5 to the power m. So this is also a rational number, but this is non-terminating but repeating. Okay, and the second part is just, I'm telling you, second part. In second part it is given that write down the decimal expansion of the rational numbers in question number first, above which the terminating decimal expansions. Means from the first question, just we have to take out all those parts which are terminating, like first part I took 13 upon 3125, and we already got that this is terminating decimal expansion. Okay, terminating. If it is terminating, then we have to show how. Okay, so first part 13 upon 3125, 13 upon 5 to the power 5, as we did already. So 13 upon 5 to the power 5, and now we have to make the pair of 2 and 5. Here in this case we have 5 times. Okay, equal number of 2 also we have to write here. So 5 to the power 5 here, so we need 2 also 5 times, because 5 came 5 times, so we need 2 5 times also. So 2 to the power 5 will multiply here in denominator for making easy calculation. So 2 to the power 5 here in denominator, so we will multiply 2 to the power 5 in numerator also. Okay, so 13 and 2 to the power 5 means 32, and here in denominator 5 to the power 5 into 2 to the power 5, and here you can see that 5 will write the power 5 alone, and 5 into 2 in bracket, 5 into 2 to the power 5, and after calculation we can get 416 upon 10 to the power 5, because 5 to the 10 to the power 5. 416 upon 1 and 50, and thereafter 1 2 3 4 50. So from the right side 416, from the right side 5, after 5 digits we will put decimal 1 2 3 4 5. So after 5 digits we'll put decimal here. And in fourth part also 15 upon 1600. Okay, first we'll simplify this fraction, this rational number. So it will be written 3 upon 320. If we'll prime factorize 320, then we'll get 2 to the power 6 into 5. Here also you can see that this is terminating, obviously, because 5 is also there and 2 is also there. Okay, other than 2 and 5, no any other came here, no any other number came here. Okay, now how we'll make in decimal form? So 2 to the power 6 and 5 to the power 1. Okay, we need 5 more, 5 we need 5 times more, so that 5 to the power 6 will come, because here in this case you can see that 2 has power 6, so we need 5 to the power 6, and we have already 5 to the power 1, so 5 to the power 5 will multiply here in denominator, and similarly in numerator also. So 5 to the power 6 it will be 2 to the power 6 into 5 to the power 6 here. Okay, and we'll write 2 and 5 together in bracket and power 6. Okay, and now 2 into 5 10, 10 to the power 6 means 1 and 6 0, and in the numerator 3 into 5 to the power 5 means 3125. After multiplication we'll get 9375, and divided by 1 and 6 0, and as we know that this is here in denominator we have 6 zeros, so after 6 decimal, after 6 digit from the right side we'll put the decimal 1 2 3 4, and we have 4 digits here only, so 2 more 0 will put here for completing 6 digits, and it will be 0.009375.